Hey folks, welcome to a new video. So in this video I mostly wanted to get started with our first benchmark. Let's say if we were to take two approaches and we were to run whatever things we have discussed till now and apply it practically to make decisions and stuff, or to see which one is more efficient and all, then this is a good place to start. So I normally have a file set up, or I normally have a program set up to run benchmarks. So it's a Python program. It's a simple Python program. You don't have to jump the specifics of it. So what it basically does is it will take normally how the graph looks like is time to memory and number of iterations to time taken, number of iterations to memory consumed, and whatever, right? So that's how it normally looks like. So it basically spits out two graphs of whatever data we give it. And I'll add this program in a gist or something, and I'll add it to the link like in the description of the video. If you need it, you can grab it from there itself. And so basically it will take your files as parameters, and it will split them into, let's say, like time and memory consumed, or it expects data in a specific format that we'll discuss, but basically that's what it does. So it will take your data, it will plot a graph of number of iterations to time consumed, number of iterations to memory, and so on, and it will give you the basic metrics that we discussed, right? So it will give you the median, standard deviation, and all those things. So basically so I just wanted to run you through this once, but then let's start the benchmarking. Let's see. First of all, I'll just start with the last thing that we discussed, SPLICE and SPLICE. So how will you jump to a conclusion for that, right? So yeah, so what we have is we start with this. We import fs. Fs is required since we will be collecting benchmarks. We will be collecting data points. We will be saving them to CSV file. Let's say for iteration 1, time taken this much, input this, memory consumed this much, that sort of a thing, right? So we need fs to like save files and all. We gave number of trials as 20, so we'll do 20 trials, and we have 5 warm-up iterations. So warm-up, as you discussed, so like for the JIT compiler to get in the flow, we do 5 warm-up iterations, and then we start the actual trial rather than starting it from the get-go. Cool. Then this is the function for warm-up. So what we are doing is, for let's say we are taking the parameter of the operation, we are taking the size, and we are taking an array. And for that operation logic, we are slicing it, and we are splicing it, right? Performing the operation that we do based on whatever we will be doing later. We just do it here a few times before, just to warm things up. And the size is basically, this is the variable in our case. So we'll try to vary the size. Let's say we want to see how these two functions behave when we change the final array size. Let's say for slice and splice, if we if for both we take out an array of, let's say we are considering array here, so I'm calling it an array. So we take out array of, let's say, size 10 from both, starting from the same index, ending at the same index, and we do the same for like maybe 1,000 times or so on, right? So that's what we are doing here. We have this warm-up function, and then there is a function called get time taken. So these are the initial arrays that we have: splice times, slice times, splice times. So these are two arrays where we will store the time values for every iteration. Memory use splice, memory use slice. Two arrays where we'll store the memory consumed for those iterations. Then we start a trial, right? So we start at 0, and then we put it on a loop. And inside the loop, we are initializing the same arrays that we did last time, right? So we are initializing large array 1. It's of 80,000 elements. Same for the second one. And then we warm up it for a while. We pass the size as 10. We don't vary that much, so we do the warm up, and for X many iterations, which is 5 for our case, it will take the size as 10 and perform the operations just for a bit of warm up. You can change this or change as per the requirement, but I'm just taking it as 5. Then what we do is we have initial memory user slice. So we check how much memory is used before we start the process, right? So it's not that accurate, but what we are looking for is not accuracy, but what we are looking for is pattern. So pattern you can spot, of course, like memory will consume of some other things that might be running on the back end, but you'll be able to see the pattern, and that's what we need to come up with a behavior, right? So here we will see the pattern, and then what we have is we do slice start performance.now, and then we calculate the end and final memory uses, right? And next we have this initial memory for splice. It's the same thing, but the operation we are doing is splice. And this is the size we are passing. I think, yeah. Oh, sorry. This is the size we are passing, slice size, and it's a variable, like it's varying, I think. Yeah, it's a parameter that we pass to the function, and based on that, it will calculate the size and stuff. Cool. Then we have this. We can add the slice size here as well, but like let's be like you can try that as well. No big deal. But basically, the purpose of warm up is whatever you are benchmarking on, it needs to run for a while before you start it. That's all. So record times for each memory uses. So we get the time for, like in splice times, we put the time for that particular iteration. Or sorry, slice times. We do the same for splice. We do the same thing for memory. Nothing fancy as such, but just a loop running and calculating the time difference, memory difference, and putting them in an array. That's all. Then we clear the arrays. This we need to ensure garbage collection, right? So if you know how garbage collection works, it basically takes out the variable of the scope which are not used anymore, and if you don't initialize them to null, or if you don't set them to null after you are done with them, it will do the same. Like after some time, it will garbage collect the variables. But if you manually if you manually set them to null once you're done with them, it will do it a bit sooner. And since time is of an essence here, we are doing it sooner, and it's like normally a good practice to follow if you can afford it, or if you don't feel like it's a boilerplate thing. But internally, JavaScript also like by default handles it, but does that it takes a while for it to realize that okay, these things are not used until you manually when you compare it with the case of manually setting them null, you are explicitly telling that these things are not used, so you can garbage collect them or whatever, right? So yeah, so we are manually doing clearing the arrays for garbage collection. So this is what we have now, and the next step is calculate the average times and average memory used. So we reduce them to the like average time, average memory, and we calculate it by the number of trials. Once we are done, since it's a loop running for number of trials, once everything is done, we calculate the average for that particular iteration, and then we push them to the files that we have, right? So we will create two CSV files. CSV files, if you haven't heard of them, are comma separated values. Those are called CSV. So as in values are separated by commas, and you can imagine it like an Excel sheet. Like if you have an Excel sheet and there is a delimiter in between, it's a comma, so it will split everything by a comma and sort it in like an Excel sheet format. So that's like the format we are following here. And then finally what we have is we have the timestamps. This is the x-axis values, the whatever we have been doing till now, where the y-axis values, time and memory. But in the x-axis we'll have the timestamps or iterations or whatever you want to call it, right? So I'm just calling it timestamps for whatever sake. Then we have some logic here to get the steps that we want to take. It's mostly like a steps. So let's say you start at 0, then you jump by 100, then you again jump by 100. So it's increasing sort of a thing, and yeah, you can like call it whatever. And basically its purpose is steps, so that for 0 you get this value, for jump 100 ahead, for 100 you get this, for 200 you get this, so that we can create a graph out of it, right? So that's the purpose of this. And then for each timestamp we calculate time taken. That's what. And timestamp is I should have called it something else, I think. I don't know why I call it timestamp, but yeah, timestamp is the slice size actually. So yeah, basically the size of the slice is the variable here on the x-axis, and on the y we calculate the time and memory consumed for whatever size we pass, right? So yeah, that's the code that we'll do. We'll just go through it once again for like if you miss something. we mention the number of trials and number of warm-up iterations. Then we write a function for warm-up. It's nothing very complex. It's just that whatever we'll be doing in the benchmarking, we just do them a bit before, so that the JIT engine can, the JIT compiler can get in flow and bring in the necessary optimizations and all, whatever is required. You can tweak these value with whatever you want. No big deal. I'm taking it as 5. Then we have get time taken. In get time taken, we calculate the y value for a given x, and for getting a y value, there also we calculate the average of it, because like I said, the more iterations you will run, the more data points you will have, and the more you'll be able to mitigate the external factors. So I could have done this just once and put that in x, but that data won't be accurate. So that's why I had a few trials for every iteration, so that I can average it out and get a value which will be sort of close to the actual value, most likely, and the probability of that will keep on increasing as you increase the number of trials intuitively. Yeah, so that's what. And then we have the large array. We do warm up, we measure the memory. For slice, we do the same for splice. We calculate the difference, we like set them to null when done for garbage collection, so that we can this is also the state part we mentioned, right? So it should have the same state. So this falls under that sort of a thing, since we are using the same array with the same elements for running all the trials or all the experiments, right? So this sort of falls under that category as well. And every iteration is like a fresh iteration, since every time we are assigning everything to null. So it's sort of like a fresh iteration every single time. So we are trying to maintain the consistent rule state here, right? Oh, consistent state rule here. What am I speaking? Cool. Then we have average times, average memory. We calculate the average of all the values, and then we put them in files, so that we have a nice file in CSV format of whatever data we are calculating. And then we have the timestamps. I called it timestamp, but it's actually the size of the array that we will be considering, like from starting from 100 till I think 80,000 or something, like till the end, right? So till the end of the array. So we are just iterating and taking steps by 100, 200, 300 and so on, right? And then for each value of that each value of that slice size, we are getting like calculating the time taken and appending the values in the CSV file, right? So now let's run it and see what happens. Okay, got it. So as you can see, it created two files, splice results and slice results. And if you see the format of the CSV, you can see that we get some random numbers and all here. So this is basically the iteration, the value that we are passing from here, right? So the timestamp value or the slice size value. For a slice size of 100, it took this much of time and it took this much of memory, if I'm not wrong, because that's the format we use, right? Yeah, it's time and memory. So that's what, this much of time, this much of memory. And this is the thing I was talking about, accuracy, right? So if you would have done date dot now, it won't go like, it won't consider these many decimal points or whatever, right? So that comes up with accuracy, because these also make a lot of difference when you are measuring it in milliseconds or microseconds or so on, right? So that's also important. So rather than choosing date dot now, we went for performance dot now, since it's considers more decimal point, it's sort of more accurate by intuition. So yeah, I think it will take a while to run. The video is also a bit longer now. So yeah, let's look at the benchmark in the next video. So if you found it helpful, maybe drop a like, share it with your friends. If you have any suggestions or anything that I can improve on, or any feedbacks as such, please feel free to comment. And if you want me to make videos on anything else, like, sure, feel free to comment as well, or maybe reach out to me on Twitter. And yeah, see you folks. Bye.